Hey guys, so today we're going to be looking at the 2021 Aime I's number 4. So the problem is find the number of ways 66 identical coins can be separated into 3 non-empty piles so that there are fewer coins in the first pile than in the second pile and fewer coins in the second pile than in the third pile. So 66 identical coins. So basically what this problem is telling us is that if we have A, B, and C be the 3 piles, A plus B plus C equals 66, and A has to be less than B, which is less than C, and we have to find the set of possibilities in which this holds true. So when I look at A plus B plus C equals 66, I think of something called stars and bars. Stars and bars basically calculates the number of sets A, B, and C that go into this equation. A, B, and C must be integers. So notice that it has to be separated into 3 non-empty piles or positive piles. And the formula for that is n-1, k-1. And we'll go deeper into that later. I just want to say when it comes to like any problem, make sure you read whether it's positive or non-negative. I know like forgetting that 0 definitely leads to many careless errors. So this is our formula. N in this case equals 66, the sum, and then k would equal the amount of terms, so there are 3 terms. So 65, 2, let's just solve for that right now. That's 65 times 64 over 2 times 1, which is 65 times 32, which is 2080. Now notice that A must be less than B, which must be less than C. Something stars and bars does not account for is order. So this amount completely disregards order. At the end, we are going to have to divide this by 3 factorial because this is the amount of ways you can order A, B, and C. I'll just write that. You can have 3 values for A, B, and C. 3 times 2 times 1. We're going to have to divide this by 6 later to account for order. Something else stars and bars does not account for is the fact that A, B, and C must be distinct. So among these 2080, there are many values in which A and B are equal or B and C are equal. So let's just solve for how many sets we're going to have to subtract. So if we pretend that A and C are equal, that's 2A plus B equals 66. And then A can equal anything from 1 all the way to 32. 2 times 32 is 64, and that way B would be 2. However, A can't be 33 because that would leave B being 0, and it's 3 non-empty. So there are 32 values for A in which this would work. And this is assuming that A equals C. A can also equal B, or B can equal C. So we are going to have to multiply 32 by 3 to account for these two. So there are 96 sets among the 2080 in which 2 of the terms are going to be equal to each other, and we don't want that. It's not like less than or equal to. So 2080 minus 96. However, we're still not done yet because we actually did over subtract another set, and that is 22, 22, and 22. And as you can see, these 3 terms are all equal, and we don't want that. 22, 22, 22 was counted as one of the sets among the 2080 that would fit into this equation. However, we over subtracted it 3 times because in this case, A equals B equals 3, and so that's 1 minus 3, and that's -2. We want 0 of these, not -2 of them, so we are going to have to add 2 at the end to account for the two of these sets that we over subtracted. And then finally, we're going to divide this by 3 factorial to regard order. And then in the end, this will give us 1986 over 6. So the answer to the 2021 Aime I's number 4 is 331. Thank you.